Hi everyone, I'm Evans Wadia representing Group 9. So these are the group members for Group 9. Our task was to perform data profiling task on frequency test analysis. So the objectives were to check for unusual frequencies, then the variables which we were supposed to do. Okay, so now we start by defining what frequency test analysis is all about, which can involve detecting or analyzing how a particular event occur within a dataset. Okay, so this technique is useful when it comes to identifying anomalies in a large volume of transaction or activity log. So its relevance to fraud detection is that it can help us to detect the outliers and also it can help us to uncover fake accounts. So we picked a dataset. So here you can see the dataset description and why we picked this dataset. Okay, so in a layman's language, for those who might wondering what a dataset is, this is just a collection of data which is basically organized and stored for processing. So dataset was picked from the UCI machine learning, then it had also these attributes. So the reason why we picked this dataset, it's because it includes real-world retail transaction from an online store. So this is the dataset which I'm talking about, which we basically picked. And from this dataset, we were tasked to do a frequency test analysis so that we can try to find out which customers were dominating and which products were being sold at a higher price, or which description or products were being sold more, so to say. So now we did a methodology which we had to do a selection of dataset. Okay, so this dataset includes the following attributes which you can see right here. Then the tools which we used, Python, and we also had to include or import rather, we imported Panda, Matplotlib, and Seaborn so that it can help us when it comes to data processing and visualization as well. So we did a frequency analysis and also did a risk assessment. Okay, so we did the findings. So these were the findings as you can see right here. So now these are the diagrams or the graphs, so to say, or the histograms which were generated, or the deliverables, so to say, which were generated with our Python script. So you can see that we are having some descriptions of each and every graph right there. So we had to do a practical demonstration as a group. So we used Python, as I said, and this is some glimpse of the codes which we basically used. So let me just dive right into the code. So this is what we had to do. As I said earlier, we had to import these libraries which you can see right here. As I said earlier, they just basically help us in terms of data processing and visualization as well. Okay, so now let me just run this Python code so that we can see what we actually did to find those graphs. Okay, so we just wait a little bit as it is loading. So basically what we are trying to find out here, we want to identify the most active customers, those with the highest transaction counts. Then we want to analyze the individual invoices to detect cases where a single product makes up over 80% of the items, flagging them, suspicious. So now to visualize our findings, we basically plot three bar charts right here. So the first chart, as you can see, it shows the top 10 most sought products From this, we can quickly spot any outliers that dominate the cells. Okay, you can see we can even spot any outliers which can dominate the cells. So let me just cancel. Okay, so the second chart here displays the top 10 most active customers, which can help us to see if certain users are disproportionately active, which may warrant investigations as well. Okay, so this is our second graph. Okay, so in our final step of our frequency-based fraud detection, we analyzed invoice dominance. So this means looking at how much a single product dominates each transaction. So on this histogram right here, you can see here each bar represents how many invoices fail or fall rather within a certain dominant product ratio. So for example, you can see here a ratio of 1.0, which means the invoice was made up of just one product repeated over and over. So this red dashed line right here marks our suspicious threshold at 80% invoice. So you can see that invoices that cross this particular line are considered to be potentially suspicious because it's unusual, for one product to make up such a large portion of customers' cut. So you can see that while most invoices have a balanced mix of products, there is a clear spike near 1.0, 1.0 mark. Why? Because it indicates a number of invoices where one item dominates the entire purchase. This can raise a red flag for possible fraud, automation, or any abnormal ordering of behavior, right? So this is what we actually did with our Python code, right? So let me just go back to our slides. So this is what we had to present as group 9. So the conclusion was that one of the lessons which we learned was the theme or frequency test analysis, which we basically demonstrated, can help us effectively in cybersecurity incident detection with minimal resources. Also, it is simple yet powerful when it comes to identifying outliers and anomalies as well. So one of the recommendations was we can just try to implement real-time frequency monitoring transactional systems using tools like Python or scripts or basic dashboards to catch anomalies as they occur. So this was our presentation as group 9 on frequency test analysis. Thank you very much.